in this lecture, we are not going to learn anything new. We are going to discuss what have we already learned. So this is a summary of all the things that we have learned in this course. The title of this course was Carbon Materials and Manufacturing. This was offered under the NPTEL scheme of the Government of India. Many people helped me, provided me with the technical support. There were colleagues with whom I could have some very useful discussions, and I have tried to include everything in this course. Before we go into the acknowledgements and I tell you who are the people who helped me, I will also provide you with a summary of whatever we have learned and what are the different carbon materials. So we started with graphite, if you remember. I recommend to anybody who's working in the field of any graphite related carbon material. So if you, let's not talk about pure diamonds, even diamond-like films, if you're working in the field of diamond-like films, even in that case, understanding graphite is very, very important. For any carbon scientist, whether you're working on carbon nanomaterials or you're working on bulk industrial carbon materials, if you want to understand a carbon material, start with graphite crystal structure. So I hope I have been able to convey this message here and there. When we were learning about a certain disordered carbon material, I told you that, our reference standard is graphite. And then we are trying to get there, or even when we are not trying to get there, or we know that we are making a non-graphitizing type carbon, still we are always comparing the properties, say crystallinity, with that of the a graphite crystal. So understanding graphite crystal structure, some of the fundamental properties of graphite, this is essential for just when you're starting, even when you're doing Raman spectroscopy of graphene, or you're working on graphene or carbon nanotubes or fullerene, any of these carbon nanomaterials. Let's say you're performing Raman spectroscopy. Now you need to understand how different it is from that of graphite. Also, in terms of when you're taking the unit cell of the crystal, that you need to understand how different it is compared to what we have in graphite, because all the inspiration of these advanced carbon materials come from graphite. So graphite is the most important carbon material. We started with that, and then we learned about glass-like carbon. Then we also talked about other non-graphitizing carbons, for example, porous carbons. Okay, so porous carbons, then we also learned how do we activate their surface and how do we prepare activated carbon materials. Okay, carbon black, yet another industrial carbon material, that is also something that we have learned. And when I say we have learned, I think mainly the properties, the microstructure, and the manufacturing process. The manufacturing process has been our primary goal. So that is something that we have learned. Okay, then we moved on to carbon fiber and carbon fiber based composites. Now when it comes to composites, we talked about not just carbon fiber reinforced plastics, but we also briefly discussed other composite materials. For example, carbon fiber reinforced carbon, or carbon fiber mixed inside concrete. So carbon fiber or other carbon particle reinforced concrete, carbon metal composites. So we discussed all of these composite materials. Then we moved on to carbon nanomaterials. I have only covered graphene and carbon nanotubes, but we also discussed fullerenes here and there. We gave examples. So we learned about fullerenes throughout the course actually, because fullerene, instead of talking about fullerene as an individual or as an industrial carbon material, what I have done is I have actually talked about fullerenes and other curved carbon structures as the building block, as a structural unit present in several non-graphitizing carbons. Okay, so you now understand properly what are curved carbon structures. Any carbon structures which have a strong enough curvature due to the presence of non-six membered rings, we call them curved carbon materials. Okay, there are many curved carbon structures that are present in non-graphitizing carbons. For example, porous carbon, also activated carbon, also other char-like carbons, and definitely glass-like carbon. And also, it's not just the complete Buckminster fullerenes that are curved. We also have, for example, carbon nanotubes that do feature some curvature. So this is something that we have learned. Okay. Interestingly, all these carbon materials are connected to each other. So I have not really, now I'll not tell you the relationship between each individual carbon materials. In fact, these arrows that I have drawn, you can definitely draw more than that. Okay, so let's say graphite is connected to glass-like carbon. Yes, we know that. Glass-like carbon is connected to fullerene. We also know that. Okay. We know that graphene and carbon nanotube is connected when it comes to crystal structure, when it comes to NM notations. We also know that carbon fiber based composites, definitely they are connected. But composites can also be made using carbon nanotubes. So there are all these carbon materials. They are connected both in terms of microstructure and property. Also in terms of application sometimes. So all these carbon materials are connected. So let's see what we have learned. Number one, the manufacturing processes. So that was the most important goal of this course, is to tell you how do we make carbon materials. Often, you can buy a lot of carbon materials. So for example, you can just go and buy carbon nanotubes and carbon fibers and then use them for a certain application. But how are these things made, and how tuning the manufacturing process can really make a difference to their properties. So this is something that was our main goal, and we have learned it, at least for these materials which are written here. Diamond-like carbon I have not written because we just, I think we had 2 or 3 lectures on how to make vapor-grown diamond and diamond-like carbon films. So, but we have not talked about the industrial production of diamond, the pure diamond crystals themselves. Okay. Other than manufacturing processes, the main properties, I said the main properties because I cannot say that I have covered all the properties for all the carbon materials, but we have definitely discussed some of the important properties. I did not give you numbers that this is the electrical conductivity or this is the mechanical property. Maybe here and there I gave you the numbers for Young's modulus, but I have not given you all the numbers, but the reference material that I have provided for the reading material, there you can definitely find also the numbers and the values of each individual property. What was more important for us is to understand why do we have these kind of properties in our material, how the microstructure and property is related. So microstructure property should actually be said, I should have written process, microstructure and property, because when we say process or processing, manufacturing process, they are the ones that are influencing the microstructure, and then microstructure in turn influences the properties of a certain material. So this is something that we have learned in this course. Characterization techniques, we did not go into too many characterization techniques, but the main techniques that are always used for characterizing carbon, for example, X-ray diffraction, transmission electron microscopy, Raman spectroscopy, and some surface area measurement techniques. That is what we have learned. So these are the common tools. These are the essential tools. So if you want to start working on a carbon material, these are the tools that you must know. But definitely there are many other characterization techniques and tools that can be used. So this is something we covered, and definitely the applications. Okay. So the important thing for this course, for me, I had 2 goals. One is that you understand the relationship between different carbon materials, and that you treat carbon as one material. Often it happens that you start working on certain advanced form of carbon, and then that is the form that you call as carbon material. Sometimes you could also say that this is carbon. It's not carbon, it's that one specific form. That's all. When you want to understand carbon, understand it from the atomic level. Understand the electron that stays in that pi orbital, unhybridized pi orbital, and in the case of diamond, hybridized orbitals, sp3 type. But in the case of sp2 type carbons, this pi electron, and in the hexagonal rings, the band that this pi electron makes, the cloud, that is very important to us. That is something we are still trying to understand. We don't completely understand it, although we do know a lot of things about this band now. But it's only very recently we have actually been able to calculate that, that there are these, what are the interactive forces between the, neighbors. What is the nature of delocalization of this pi band electron? This is something we need to understand first for understanding any carbon material. So start from here. When you want to work on any carbon material, maybe you are just, you're just making a device and you don't care about the material very much, but you need to understand the properties, right? And you also need to understand, can you tune these properties? So for understanding that, it is very important that you treat carbon as one material, not just a certain form of carbon should be considered one carbon material. So start with carbon atom. That was the goal. Okay. What else? So yeah, this is what I have just mentioned. Carbon should be first studied at an atomic level. Actually, this is not just true for carbon, it's true for any material. that you first try to understand it at an atomic level, electronic level, even before that. So when I say atomic, that includes electronic interaction, electronic behavior. So understand the material starting from there, and then go to crystal structure, then go to large scale. Okay. Now, one more important thing is that, and I hope again I was able to convey that, it's best to study carbon as a material manufacturing pair, because every carbon material has a different manufacturing process. Some things are common. Carbon is often made from organic precursors, whether they are carbon nanomaterials or large scale materials, industrial carbons. We often have an organic precursor, and somehow we use high temperatures to get rid of the non-carbon atoms. So this is the fundamental principle which remains common. However, the precursors can change, the manufacturing techniques can change. For nanoscale materials, you may have a completely different type of furnace or reactor. For large scale materials, you'll have different furnaces and also different parameters. If you're using a gas phase precursor, then your parameters are completely different compared to when you're using a solid state precursor. And often you provide a shape already. If when you're using solid state or liquid state precursors, then you often provide a shape already to the precursor and then perform the heat treatment, like in the case of carbon fibers, or even when you're making glass-like carbon structures, microfabricated structures. So irrespective of the manufacturing technique, it can be very large scale manufacturing, it can be micro scale, it can be nano scale, it can be an atomic deposition. Some fundamental principles are common, but also there are various differences. So the best idea is to understand carbon materials in material manufacturing pairs, and that is also one of the things that I have tried to achieve in this course. So every time we did not talk about materials separately and manufacturing process separately. We talked about every carbon material along with its manufacturing. Okay. Yeah. So bulk industrial carbons you need to understand first, then go into nano materials. You can also say that why not I first learn nanomaterials, then go into bulk industrial carbon. Okay, that's also fine, as long as you understand both. Okay, so bulk industrial carbons can in fact also provide you with a sort of a platform that will be useful for you to understand nanocarbons. But my point is that don't just learn about one carbon material, learn about the history also. Okay, yeah, talking about history. When I talked about history, then we also talked about the nomenclature, how it has changed over time, and what are the things that we need to ensure. My personal recommendation is that use the correct nomenclature. If it is graphene only, then call it graphene. If it is graphite only, then you call it graphite. If it is graphitic, you should know what you mean by graphitic. So all of these things, I hope the students will take this responsibility, and in the future, at least we'll get rid of some of the confusion related to carbon materials. On this slide, I have mentioned the names of a few books. Okay, so I have only written books and not journal articles because you see, number one, I already provided the links to some of the journal articles, some of the review articles, especially whenever we were discussing a certain topic. But also there are many other articles that you can find for yourself, and there is an overwhelming amount of literature when it comes to carbon materials. So definitely you will find a lot of information, but sometimes it can also be too much information and you can get confused. So in that case, books help more. Okay, at least that is my personal opinion. So these are some of the books, and please note that these books are not in the order of preference or anything. In fact, I think they are in the order of how they fit, how they best fit on my slide. So that is not the case. These are just some of my favorite books, but also it is quite possible that I read some book somewhere which is in some library and I don't have it with me right now, and that is why I have not used it for this particular course. But you know, the things that I learned from those books, they were right here. So yeah, it's not that I have been able to capture all the books, but these are some of the books that can be very helpful if you want to learn some fundamental things about carbon materials. Okay, what else? Yeah, I have although covered some concepts of carbon nanomaterials, but in the books section I have not written any book which is very specific to, say, graphene or carbon nanotube and so on. The reason for that is that my personal research work and my personal interest is more towards bulk carbon materials rather than carbon nanomaterials. At least as on date, I have not worked on these carbon materials which are fabricated using bottom-up processes and so on. So these carbon nanomaterials I have not worked on. So that is why I do not really have any personal recommendations when it comes to the books on carbon nanomaterials. But again, there are many books available. Okay. What else? Again, I would say that please take care of the nomenclature of carbon materials, and whenever you have a confusion, then you have one gold standard, that is your IUPAC gold book. So whenever you're confused, refer to the IUPAC gold book. On this slide, I have mentioned the names of all those people who were directly or indirectly involved in this course. First and foremost, both my teaching assistants, Mamta Devi and Mohit Sahu. I'd really like to thank them. The video recording would not have been possible without their constant support. Also, they helped me, with drawing some of the images and so on. So I'm really thankful to them. I'd also like to thank some of my colleagues and friends with whom I've had discussions at various time points on different topics related to this course. Arvind Fura, Sudhir Pandey, Bhaskar Mondal, Vishwanath Balakrishnan, also various members of the Indian Carbon Society. When I was designing this course, I was not sure if certain topics should be included, or maybe I was missing out on certain topics. So I had detailed discussions with Dr. O.P. Bahal, and then that actually helped me design this course. So I'd really like to thank the Indian Carbon Society, all the members of my research group. Some student must have collected some data which I have used in this in my slides, probably without even acknowledgements. I'd like to thank all of them. NPTEL team has been really supportive, so I'd also like to thank them, and of course everyone at the IIT Mandi.